No, this is okay now. I can.
Yes, sir.
Yeah.
Hello.
Hello.
Everyone.
Yeah.
Hello, everyone. Present here virtually. I am Preeti here and welcome you all for today's session, which is
Can we start now? No? Hello. എത്ര ഉണ്ട് ഇപ്പൊ ബിയോഡി? നമുക്ക് രണ്ട് ഇപ്പൊ 6-ാം തീയതി വരെ 2 പ്രാവശ്യം വന്നു.
Just a minute, sir.
ഞാനൊരു മീറ്റിംഗിൽ ഞാനൊരു ഓൺലൈൻ മീറ്റിംഗ് ഞാൻ വിളിക്കാം. യാ
Hello, everyone. Present here virtually. I am Preeti here and I welcome you all for today's session, which is titled as Lean Management in Manufacturing Process. And presenting this session, we have with us our today expert, Venugopal S. Sir. Venugopal S. is a Joint General Manager in HLL Life Care Limited Factory, Trivandrum, in various functions such as production, testing, quality, safety and environment management representative, include chemical engineer with total 28 years professional experience. He is a certified Six Sigma Black Belt and lead auditor in quality management and assessor of business excellence model. He is recipient of various national and international awards from various agencies. Without wasting much time, I welcome to Venugopal sir. You may start now, sir.
Okay, good afternoon all. So thank you for the nice introduction. So I will come to my presentation on lean manufacturing for manufacturing competitiveness. So basically, lean manufacturing is is a tool for improving the manufacturing competitiveness and to improve the quality as well as the product as well as the service. So basically, let us see some introduction part. So basically, every company wants to grow at 15 to 20% profit every year, and it is a growing pains. And their products will be accepted, some products will be rejected, etc. Or so that is the current scenario. So the customer says, "Hasta vista, baby." So coming to the history of lean manufacturing, basically in 1850, the quality revolution starts after the Industrial Revolution. So it starts with the craft manufacturing in 1850s, then followed by American Civil War, which involved the machine tool development, and 1900 the Taylor has developed the standardized work time study and work standard, and the Gilbert has been developed the process chart time motion study in the World War I, and World War II we have the Duran, which is a quality specialist involved in statistical process control and total quality management. Followed by 1950 we have Toyota, then Shingo, etc. We follow the Toyota production system, just in time, then world-class manufacture, stockless production or zero inventory, and 1990 comes the concept of lean manufacturing. So these are the issues which lean manufacturing has been addressing. Basically, the inventory on the stock room is gross, so we have to reduce the inventory. So the lean manufacturer takes care of the inventory. So how do we grow? So how do we make the right product of the time? Or we have to make a competitiveness in our manufacturing facility by improving the product cycle time. Then how do we lower a stockroom inventory, or we have to have a mechanism for reducing the inventory? How do we maintain a good quality product? We have to maintain zero defect in the product as well as the process. So these are the areas where lean manufacturing, how do we grow? What is the growth or strategy which we are following in the business? So these are the questions which are in front of us. And the answer is we could hire more people and buy more machines. Or other strategies, we could raise the price of our product, which is not practically feasible because the customers, there are a lot of competitors in the market. The customers are there. We could hire more people and buy more machines. Then also we lead to the less productivity for the or less profit for the organization. So currently our customers are asking to reduce the price of the product. So in the competitive scenario, there will always be a concept of cost reduction, and the customers are asking for price reduction. So before we do anything, we need to become we should be more efficient in our manufacturing, and we need to find the waste in our process. So the waste is called the lean man. So our process should be lean in the sense we have to find our waste and we have to cut out the waste so as to process becomes very robust, or it is very simple, or it is more efficient in manufacturing. So the goals of lean manufacturing is produce more product using the current resources. No, that means we have to produce more product using the current resources. We have to improve the productivity. Let's just lower the stockroom inventory, or we have to reduce the inventory. Then we have to make an accurate forecast exactly how long it takes to make the product and ship them on the time. So we have to give the customer the product at the right time, at the right place, at the right and all of that need is to assemble at the right time. So the right time is the place is a more major philosophy which we follow to maintain the customer relationship or to enhance the customer satisfaction in the process. So coming to lean. So what is meant by lean? You can see here an elephant and a rat. So basically, lean is a systematic approach to identify and eliminate waste through continuous improvement in pursuit of perfection. So all the process should go to a stream of perfection. So once you are perfect in the process, then you will be able to apply the lean, or you will be able to reduce the rejection or wastage, or we can reduce the inventory, etc. So that what we have to do is now first we have to identify the waste which we are associated. So it is coming on what are the different types of waste that is coming in the next slide. So we have to identify the waste associated with the production activities, and we should have a mechanism to eliminate the waste through continuous improvement. We have to make we should not stop our activities assuming that everything is perfect. No, it is not like that. We should have a system of continuous improvement by identifying the waste, then eliminating the waste through the continuous improvement in order to have a path of perfection. So that is called a lean. So the lean means the process will be very robust. We will be identifying the defect or waste, and we are taking steps to eliminate the waste. So that is called a lean. So the purpose of lean is to striving to do with more with less and to do it consistently. We have to make a consistent product in the course of production, and we have to work smarter, not harder. We should be smart enough to work so that we will be achieving the goals. So the lean, another definition of lean is defined as it's a systematic approach. Basically, it's a systematic approach to identify and eliminate the waste. So it's a systematic way we have to identify that, and we have to take action to eliminate the waste. What that's called a non-value added activities. So we have to consider only the value added activities during the process, all the non-value added activities in the process, which we can eliminate through continuous improvement by following the product or process product and the pull of the customer in product. But there are two concepts called pull and push of the customer. Pull means the customer takes the product from the previous. We have an internal customer, and the internal customer will take the product from the previous process, and they will pull the product from the previous process. And also the final product also the customer will pull the product from the company. That's called a pull. So basically, other concept is called a push concept, where the customer does not want the product. What the manufacturer do is the manufacturer will push the product into the customer's go down. Or if it is an internal customer, then what we do is that we have to push the inventory to the the process owner, etc. So we should be pull the customer, which the concept which we have to follow is a pull concept, not the push concept. The push concept will increase the inventory of the product, whereas the pull means no, the absolute the inventory is reduced, and whatever customer needs that will be taken from the godown, etc. So lean manufacturing, we have to follow a concept called pull concept for perfection. And first, it is a systematic approach to identify the non-value activities by eliminating the waste through continuous improvement by flowing the product. So we should have a product flow line. We should have a system of elimination of waste. For that, first we have to identify the waste. Then we reduce the non-value added activities to eliminate the non-value added activities, which is done through continuous improvement by flowing the product at the pull of the customer, not the push. So this is the definition of lean. So basically the lean, there's a formula for the lean. So the lean involves a combination of the teamwork, observe, communication, culture, and ideas. Basically, it's an HR-oriented concept and also an operations management concept wherein the teamwork means it's a team of people who actually do the work. With a single person, you cannot achieve the goals. So the team means, the lean means it is a combined effort of all the people involved in the team to work actively and to achieve the goal. So first we have to develop the ideas. So that's the most important thing. We should have a brainstorming session to conduct how to eliminate the waste for the process. So we have each team member develops the idea. So and there should be a culture of continuous improvement in the organization. The organization should have a concept of consider the new ideas, and they should have a platform to encourage the employees in a very competitive manner, so that culture of continuous improvement culture. Then only the people will think differently and they will implement things now. So once it is the ideas are identified, then it will be communicated to all the people, the change being implemented, and the success and failures relating with the change it has been implemented, and that will be communicated to all the stakeholders. Then we have to observe the current situation. Then based on the current situation, we will see what is the level of improvement we achieve. So this is the main concept of lean formula, which involves teamwork, ideas, culture, communication, and then we have to observe. Okay, so there's another concept called lean toolbox. So generally tools, what's in by tools? So it involves different types of tools, etc. in lean. So what we are for effective implementation of lean, we have to adopt each of these tools. So that we are coming in the next slides. So the first is we should have a 5-year system. Before implementation of lean manufacturing, we should have a 5-year system. 5 years means maintaining the housekeeping or maintaining the good cleanliness at the workplace, which involve first we have to sort the waste, set in order, then we have to shine. Shine means we have to make it all items in a perfectly clean. Then we have to follow rules and we have to sustain the rules. So that's called a 5 years concept. So once the 5 years, it basically is a cleanliness concept. So once the 5 years is implemented, a team should be developed. So that is called the team formation. Then we should have a quick change, have a standardized work practices. We should have an SOP. We should have an SOP or standard operating procedures relating to each of the activities, so as to have a standardized workflow. So we should have a standard operating procedures in each of the places. Then we should have a visual control. So any control in the process that can be done through visual controls, so that each person who is doing the job, they will have more accurate or more awareness on that. And the awareness creation has been done through visual control. Example, the rejections and wastages and other defects in the manufacturing that can be made available or can be communicated through visual control, so that it be more clear to the people. Or then we should have a quick changeover. We should have a good changeover. If you have a product changeover from one pattern to other pattern, or you have a different scheme or different mode of product, then it should be done at the earliest possible. Otherwise, it will lead to this increase the cycle time. Then we have the batch reduction. Look. Yeah, this is a meeting. Yeah. Then we have batch reduction. Batch reduction means the batch, we should have the number of batches produced will be less. We should have the batch size we have to optimize the batch size, so that the number of batches produced should be minimum. So that's called a batch reduction. So for that, we should have an effective plan layout. Then our layout should be very sensitive, so that there will be flow of materials, and we should have a proper control over the workplace environment. Then we have production cell. We have a different types of, based on the layout, we should have a production cell we should have. Then we should have a quality at the source. So that's the most important thing for implementation of 5 years. That is quality. We have to find the quality at the source. The person who is doing the job, he is responsible for ensuring the quality of what he has done. So generally in all manufacturing organizations, there will be a production department as a QA, as a quality assurance department, or a manufacturing department, or whatever department may be. So first, what they have to identify is the quality at the source. Just who are doing the job, they are the quality inspectors. They should ensure the quality. It is not the job of the QA department or the quality control department to ensure the quality. It is the role and responsibility of each one of the organization to ensure that the job or whatever work they are carrying out is best in quality. So it's called the quality at the source. So basically, it's a philosophy and as a culture for implementation of Lean. Then we have the point of user storage. So the point, because point of user storage in the sense, whoever is maintaining this or responsible for that, no, they should have a responsibility for the store. That is, if we come to inventory, everybody is responsible for the inventory who are carrying that. So it is a point of user storage. Then we have production cell. So each of the activities can be bifurcated in the production cell so that the smooth flow of product is being ensured and there will be minimum loss associated with the product. Then I told you about the supermarket flow pull system. So we should have a pull. The customer should pull the product from the godown, or if you consider the internal customer should pull the product from the previous customers, etc. like that. So the concept of pull should be emphasized, not the push system. Then there should be total productive maintenance. So that as like quality management, we should have a total productive maintenance. So there will not be absolutely zero maintenance or zero breakdown. So we should have a system to ensure that the machine is not under breakdown and the running condition and the production losses happen should be such that the machine maintenance should be done well in advance and based on different techniques like predictive maintenance or autonomous maintenance or preventive maintenance, etc. So that the machine downtime can be made zero. So these are the various tools for implementation of Lean Six Sigma, where Lean manufacturing, where we are involved. The 5 years practices should be there. Then formation of team. Then we have a visual control. We have a standardized workforce. Then we have the batch reduction, or the batch size should be optimized so that the number of batches produced will be less and should have an effective plan layout. Then the production cell we should have. Then the quality should be at the source. So who are responsible to carry out the job, they will be responsible for quality. Then the pool system should be followed and the point of user storage, and we have the total productive maintenance. So these are the various tools of lean manufacturing. So one of the most important terminology or technology generally used in lean manufacturing is the term called waste. So the waste. So we have to eliminate. So what we have seen the definition. So we have to eliminate the waste. So waste is the Japanese term. So basically, lean manufacturing is a Japanese concept, and it is called a muda. Muda is a waste. So it means the minimum amount of materials, equipment, parts, space, and workers' time, which are absolutely essential to add value to the product. So we have to reduce the waste in terms of time, in terms of quantity, in terms of resource utilization, and in terms of the spares, in terms of inventory. All these things are contribute to the waste. So we have to reduce the waste. So that's what the concept called muda, or the waste. So the lean manufacturing involves the reduction of waste or elimination of waste from the process. Now let us see the different types of mudas associated with the lean manufacturing. So basically Toyota is the first company which we have implemented the lean manufacturing in India, and which produces, there are 7 types of muda which we have identified in the manufacturing system. First is called the storage, second is called transportation, third is called waiting, fourth is called motion, next is process, then defects, then overproduction. All these are different types of waste associated with the manufacturing system. Storage is now, if you have storage in excess quantity, that will be a waste. So that means high inventory. If you keep higher inventory, that will be a waste. Then transportation. If you transport the product from one source to other, if you take the longer transportation route, that may lead to more wastage in product. So we should have a system to optimize the transportation system, etc. Then waiting, if you wait the product, so that will lead to additional cost, waiting time, queuing costs, etc. That will lead to the waste. Then motion, unwanted motion of the operator, etc. in doing the job. So that should be the work should be standardized, or standardized work practices should be followed so that the waste can be eliminated. Next, the called process. The process, there will be rejections are coming. The process, when the process is running, there will be rejections are coming. So we have to reduce the process rejection, etc. Then defects. The defects generating from the process, that also lead to waste. Then we have the overproduction. If you want to have overproduction, means whatever the customer wants does not have quantity which does not needed, etc. That is excess production. So that is a overproduction. That also is a waste. So these are the 7 types of waste generally followed by any manufacturing organization to implement the lean. So we have to address all these 7 mudas to ensure the efficient lean manufacturing practices. So this 7 ways can be represented like that. You can see the first is called overproduction. I say about the customer. We produced some product in anticipation of customer orders without doing a better forecasting facility. So that will lead to overproduction. So after a period of time, that will be getting wasted. The raw materials, the finished product, all this manpower, so everything will be wasted because of the overproduction. The products are manufactured without considering the customers' needs and expectations, and the forecast. Actual forecast is not being met. Second is the inventory. So we should have a raw material, work in progress, or finished good inventory, which is not value added activities. So that will lead to the waste. Third is the waiting. So if we want to, if a product is being waited in the machine for a long time, that is due to the bottlenecking, or some parts are not generating due to the breakdown of the system, or the machine will takes more time to carry out a particular job, etc. That will lead to the waiting of the job. So that also is a waste in time. Then motion. The motion in the sense I told you, the unnecessary movement of the people, parts, or machines within the process, etc. And we have the transportation, means unnecessary movement of the people between the process. That may lead to the accidents, the product mix-up, then product packaging issues, etc. Then rework. So basically, once you do a job, you should have to ensure that there should not be any repetition of the process. So if you are not doing the thing the first time, then again we need to rework. So the lean manufacturer address the philosophy that doing the job the first time. Even the first stage itself, you should ensure that you are doing the right job, and there are nobody else for correcting you in the process. So that is the concept called rework. So everybody are called the process owners. They are responsible to ensure the responsibility in their areas in which they are working. Then overposing, that is the customer wants a specification. If you are doing an over design and we do an over processing which is beyond the standard or beyond the requirement of the customer, so that will also lead to the additional cost as well as the time. So that also is a waste. So all these are 7 types of waste associated with the lean manufacturing. So once you eliminate all these 7 waste, definitely your organization or your process becomes very lean. So this we can even apply to our domestic life or family life, etc. Overproduction, inventory, waiting, motion, transportation, rework, and overprocessing. So generally, basically the concept of lean arises due to the variation or variability in the process. So in universal we can say that no employees, no machines, and no suppliers there's a standard specification are exactly same. We cannot see all the employees in the organization same. Everybody will be different. The machine also same, even though the same technology machine, similar type of machine, similar specification of the machine, but the machines behave differently only. Not all the machines should not behave the same manner. And suppliers, even the same supplier, if you are giving the product in 2 periods, that will be different. We should not ensure the same quality throughout that. So same is the case with the same product which is being supplied by different suppliers. That also we cannot ensure that all the products should be of the same standard or same quality. There will be variation, of course, in the process. And variation in the sense there will be variation in the engineering drawings or specification, and the production personnel try to produce before drawings or specifications are complete. So we have to make a perfect drawings and specifications based on the customer demands. And basically all these are doing based on the customer demands. Then there's a continuous flow. So in a lean manufacturing, the process should be continuous because the products are produced and moved from one item at another at a very small and a consistent batch of items through a series of process continuously as possible. With each step making is what is required by the next step. You have to make the process based on what is the need of the customer. If you have an internal customer, if we have an internal manufacturing system, we should have to ensure that the internal customer should be aware of your product, and based on their needs and expectations only you make the products. So it is based on the needs and expectation of the customers only you make the products. Then the product, then only that we can say that the product is consistent, etc. So this is called a one piece flow or a single piece flow, and make one or more one, or it's a standardized product which is meant for a specific customer, specific product, etc. So that's called a continuous flow, and which involve the producing one items and items over a continuous as a batch, etc., through a series of steps. So that's also called a mass production. So the mass production means the batching. So we have to make different batches and different process, and we should have a queuing of the batches. So we have to wait for the, so that's called a mass production. So lean production is there's no queuing, etc. There's no batch. Once the batches are produced, there will be different process. There will be different batches produced, and it's a continuous flow with a minimum lead time. In the mass production, there's not a systematic approach. There should not be any lead time. Lead time varies from process to process, and it may as a batch, and some batches now we need to have a waiting time, etc. But for lean production, absolutely there's a continuous flow without any queuing of the process, etc. And we have to calculate the lead time in minutes. So you can see the difference between a traditional flow and a flow. And traditional flow means we have a supplier, supply the product, you keep it as an inventory, you make production. Once you make the production, some materials will be kept as inventory. Then the product after manufacture will go to the customer. So that is the traditional flow. Now we have the flow with the JIT, just in flow. So generally there's a concept called just in flow or a zero inventory, like what we needed for implementation of lean manufacturing. So this involves the suppliers and customers. Suppliers provide the material to the customers at the time which the customer needs. So that means we are not keeping any inventory. If the customer asks for a product, the supplier will immediately deliver the product. So based on the customer, because based on the customer needs and expectation, they manufacture the product, and based on the customer expectation, they will deliver the product. The suppliers will deliver the product. So basically, there is a concept of zero inventory. It's called a just-in-time production. Zero inventory with no go down or no storage space, etc. So whatever the customer needs now, immediately it will be delivered to the customer, etc. by the supplier. It involves zero inventory and zero cycle time reduction, etc. So like this, I have mentioned about the push and pull. Push system is generally is pushed into the downstream workstation means it will be the next station, regardless of whether the sources are available, whether they are requirement or not. Because in the push system, it is not considered the needs and expectation of the customers, etc. So whatever product produced is being dumped or it is being transferred to the next station. Pull system means the material is pulled at the workstation. The next workstation will pull the material from the previous workstation. So that means based on the requirement, they will pull that. So there will not be any inventory, etc. So it will be a better system. Pull system will be a better system compared to push system, in the sense it will reduce the inventory. Pull system will reduce the inventory. So you can see that this Toyota, they have a system of this push-pull system for material resource planning, material requirement planning, etc. They are following. So here, if you have a JIT or just-in-time, so just-in-time system is very effective for implementation of lean manufacturing. Here, the production of items is based on only demand for the use, and it's only based on demand. We are not manufacturing the product in advance or replacement, etc. Only based on the customer demand, only we are manufacturing the product through different systems like a Kanban card. So a Kanban card means gives an indication to the process that you should make this much quantity of production because this much quantity will be needed for the customers, etc. So based on that, the Kanban card, the production will execute the order, and then the product will be delivered to the customer, etc. So that will be at the very minimum time, etc. So this is called a JIT system. So next is very important term called Kanban. So Kanban basically it's a Japanese word which is called Kanban, which authorizes the production from downstream operation. Which because in the Kanban system, you take the production from the downstream workstation. So we have to pull the materials through the downstream station. So it can be a indication, can maybe a card, flag, verbal signals, etc. Open. They are mixed with the different fixed size containers, etc. They add or remove the containers to change the production rate. So they give an indication on the previous workstation that the product is being finished and you have to start production. So there will be two Kanban cards generally. So the Kanban is represented by a triangle. So it is called a triangular Kanban. Of course, there will be a circular Kanban also. So here each part. So this will be helpful for identification of the tools for each of the parts and also for the assembly areas where a lot of components are involved. We can use a Kanban system for effective control of the raw materials. So these are triangular carbon. We have different types of products or what is lot size. So machine, all the details can be put the card in the card along with the product, and there will be a product. There will be two types of cards are there. One we have a production card, and then we have a transportation card. Production card will be transferred from one station to other, and transportation card will also be transferred from one station to other. So when the last station receives the product, so their consumption will be over. So that means they will give an indication to the previous station mentioning that the material is in short supply, the material we require material, you supply the material. So accordingly, from the next before process owner, they will intimate to their process owner, etc. So like that, the cycle will be completed, so that production will start. So Kanban ensures that the product is produced only based on the customer demand and not based on customer anticipated inventory. Only based on customer demand it manufactures, so that which eliminates the waste, so that all the manufacturing products are manufactured as and when only it is needed. That is called a Kanban concept. So you can see the Kanban, we can put some cards also, like it's a hanging. These are go down where we have a box, we have Kanban. Also, we have a Kanban system is there, or Kanban tool where we have post is there, where we have the different product codes are being displayed. Whenever it is being displayed means no, the product stock is not there, immediately production will start. So this post will identify the normal locations where we can see the product. So there's also a concept called the economic order quantity. So based on how much order quantity which we need to manufacture or maintain, so as to have a zero inventory, or we have to inventory reduction. So that can be maintained through a basic fixed order quantity model. For this model, we can have a reorder quantity or economic, what will be the minimum order which you can order at a particular time, or what will be the reorder point, how much stock you need to keep scientifically. So that's called a reorder point. Lead time is the time taken to purchase a material from the supplier. So these are the various strategies which we follow for inventory control reduction. So then we have a Kanban system. I told you there will be a two card. One is a production card as well as a transportation card. Production, it's a single card. So once the card is ready and it has been transferred to the previous owners, they will start the job, and also they give indication to the next previous process, so that production will start. So basically, Kanban system is a single card system which moves along with the containers. Then we have a dual card. That is, I told you about the production card as well as the transportation card, so that there will not be any transportation delay. So once the product is being transported from one station to other, transportation card will be removed, and once the product is being consumed, then there will be an indication that you start the product from the previous process. Like that, all the process owners will be intimated to start the production. So along with that, the transportation card also being generated, so that the time taken to transport the material from one station to other can be estimated. The function of Kanban is the function of inventory reorder point. Now coming to inventory. So inventory, we discussed about the traditional inventory, that is inventory exists in case problems arises. Then we have a just-in-time, which the objective is to eliminate the inventory. So just-in-time generally requires small lot size. Generally, they maintain a small lot size, because if you have a higher batch lot size means no, if it is excess inventory, we cannot use it like that. So that the inventory will be a small lot size, low setup time. Production changeover time will be very less, and containers for fixed number of parts. Each of the containers will be labeled and identified, etc. So JIT inventory minimize the inventory to keep the system running. Then in lean manufacturing, there's another term called Hejunka. Hejunka means smoothing of production. So that means we can have different models, mixed model, which we can smoothen the production. Smoothen the sense, we should have to level the production. So we cannot have an excess inventory or excess quantity of product produced in any of the point. It should be constantly maintained. That means the output of one process will be the input of the other process, etc. So you should have a customer oriented process, etc. So that you should have a equal leveling of the production in each of the stages of production. That is called hedging or smoothing or leveling of the activities in production. It will reduce the nipple effect of the small variation in the schedule. Any small variation in the schedule which we can address, then production quantities are even distributed over time and build the same mix of products every day, and results in many lots, etc. So that can be ensured through smoothing. This is called a hedging or leveling or smoothing of the production, etc. So that we can have a uniform stock throughout the process. You can see this concept of small lots versus large lots. So the small lots, if you have a small lots means the number of lots needed is more. If it is a large lot, okay, large lot, then we have the number of lots produced is less and we should involve the time. So we have to optimize the time and accordingly optimize the batch size so that the cycle time can be reduced. So JIT produces same amount of the same time if setup times are lower. Same lot also increases the flexibility to meet the customer demands. Lowering inventory reduces the waste. So lean focus the principle that if you lower the inventory, then definitely your waste will be reduced. So we have a work in progress, scrap, etc. So if you have a unreliable vendors, then we should have our inventory will be more because we should have to stock more items to avoid the stoppage, etc. So we have work in process inventory level is high. Then we have a lot of issues relating with the rejection, etc. And the capacity becomes imbalanced. So we should have a system to balance the capacity, the process. Next is lowering the inventory, reduce the waste. If you have less inventory means our waste will be very less. If you have more inventory means the waste will be high. The people will use over consume the material that will lead to rejection and waste that will be kept on the floor, etc. And some will be some will be generating as a waste, etc. So all this reduces the waste. So lowering inventory reduces the waste. So reducing the inventory levels problem they can be solved, etc. So we have unreliable vendors, then scrap, then we have the capacity, then we have a capacity balance. Then we can go for this concept. The lowering inventory reduces the waste. Reducing inventory reduces the problem that can be solved. So by all the problems associated with the process can be solved by reducing the inventory recourse. Then to lower the inventory, reduce the lot size. So we can have a system of inventory lower, which will reduce the lot size. So we can fix what is the economic or batch size needed to maintain the order quantity. So yeah, reducing the lot size, increasing the number of lots. So we can have with a reduced lot size, we can increase the number of lots. So all these are various strategies which we can follow to reduce the cost, manufacturing cost. So which increase the inventory cost? There will be a total holding cost, there will be a setup cost, and there will be total cost, there will be a smaller lot size, etc. All this cost involved in that, we should have an optimize so that the total cost will be less. Then we have to setup costs are reduced. We have to reduce the setup cost. Setup cost means time taken to manufacture. Once you have all the materials, get the machine adjustment, that is called a setup, machine setup time. So that should be reduced. So quick setup means quick changeover. That means if you have one product running in a line, next line, and we should have a system of such that a new product is being running. So we have to reduce the changeover time, reducing time or changeover time, which is a percussive to the lot size reduction. Also, we have in the quick setover, we have a concept called single minute exchange of dice method, because single minute exchange, if you want to have a die change in the machine, we should done at the earliest. So that's called a single minute exchange. If you have the changeover time is more, then your issues will be inventory and wastage analysis will be on the higher side. Then the method has been developed by Toyota and Shingo, etc., which has proven to be effective in many organizations by reducing the changeover time. The setup components. So some of the components which you are using the product that also can be used. So the external setup cost is there. We have the internal setup, which involves the setup activities which we need to carry out while the machine is running. External setup means the activities which we can carry out while the machine is still operating, we can do some jobs. That's called external setup. It is very desirable to convert as much internal setup to external setup. The internal setup improves the setup procedures. Then I told you about the quality at the source. So that is most important thing. Quality we need to maintain at the source. So doing it right. So whatever we are doing first time should be right. So doing it right the first time. So that the philosophy of lean manufacturing. The JIDOKA allow workers to stop production line. So the workers are free to take decision and to stop the production line whenever is there any non-conformities or anything is noticed. So workers are free to take a decision. So they can allow the operators to stop the production if they find excess rejections or process failure. So it's called a JIDOKA. Then there's a concept called Antone. So Antone is a process where we have lights, where the Antone light signal sort out the quality problems, etc. It gives an indication about the quality problem so that the operator will be more vigilant and he will run the machine. So the next is the under capacity schedule allows for planning problem and so. So one of the most important bottleneck associated with the lean manufacturing is the under capacity scheduling. So you have an excess capacity in the process. So our capacity is less. So we want to plan for under capacity. So that leads to a lot of issues, etc. And that it affects the planning process, problem solving, and also the decision making process, the under capacity scheduling, etc. And visual controls make problems more visible, etc. And Pokai, okay, that's also a Japanese word which will ensure that the defects are eliminated. So if you have a defects now, you should have a system to reduce the defects. So that is called a Pokai, okay. So next comes to a concept called the house of Toyota. So Toyota, I told you about the first company, they introduced the lean manufacturing. So their concepts have been developed through a house of Toyota. So the goal is highest quality, lowest cost, shortest lead time. So we can have it just in time, which includes continuous production, top time, full system, etc. JIDOKA, we have stop and notify abnormalities. Then we have a separate man and machine work, etc. So basically, we have a stable workforce which consisting of Hejunka, standardized workforce, then Kaizen. So these are the various pillars of lean manufacturing. So it has been suggested by Toyota. It's called a house of Toyota, just in time and JIDOKA. So I told you that the Toyota production system is supported by two pillars. One is a just in time and a JIDOKA. JIDOKA means automation or automation with human intelligence. So we should have a system of automation as well as automation with human intelligence have been taken care. That's done through AI, virtual reality, etc. So basically, this Sakichi Toyota formed the Toyota companies invented a concept called JIDOKA in the early 20th century by incorporating a device of the automatic looms that will stop the loom from the operating when they find that when a thread is being broken. And Shingo then developed the idea further. This enabled great movement in the quality and freed people up to do some value addition more than what they are doing that, etc. So this simple concept found is very effective in every machine, every production line, every Toyota production. So there are different types of JIDOKA techniques which we can apply in industry. One is called Pokai, okay, or mistake proof. Generally, it is used by all industries. So basically, it's a mistake proof strategy. Or if you have a mistake, it is have the feeling that the operator will make mistakes. So we should have a system in place so that should reduce the wastage, etc. So it is called a Pokai, okay. It is called a mistake error proofing. So it is a form of a device for building quality at the production process, and the device may be at the right design. And there are different types of Pokai, okay, such that we have proximity switches, stencils, light guards, alignment pins, etc. etc. So the main goal is finding zero defects, which they of course, or the defect should be zero, and we have to follow SQC techniques, statistical quality control techniques, for finding the defects after they occur. Or we should have a concept called visual management, which includes Antone lab that I discussed that earlier. We should have a system to the operators or people who are operating the machine. They should have a system to give alarm that your product, the production process which you are running is wrong, or it gives a visual display or visual management by providing by a lamp. So it's called a visual Antone lamp. So like there are different examples. Okay, mistake proof activities. So that I will be skipping now. That is mistake. We should have a system of reducing the mistakes. You can see the non-visual example, view of manufacturing floor. You can see the manufacturing floors are being kept with this storage rack that can be visible. View of a manufacturing floor, which involve different types of machines, different products, storage, etc. All that comes under it. Then we have a view of the manufacturing is called a 5 food standard. We have a 5 feet standard either. Then you can see the hand-on lab. Then red line in the production. We have red line stoppage. Then we have yellow call for help and green for normal. When the normal operation is being carried out, there will be green signal is there, and yellow means when stoppage is there, the machine will show the alarm as red. And if the operator wants to have a help from the even from the machine or from the maintenance team, etc., they should have press it. Then will be yellow will be glowing. So that is a visual display which can be addressed for effective communication in the workplace to reduce the defect. So you can see the as a visual example, you can see there are different color coded tool trays which will be kept in the respective locations, etc., or earmarked area so that it can be tracked by anybody else in the organization. So that's called a color coded tool trays. Another improvement in lean is generally people will follow a concept called the Kaizen. So that's also a Japanese concept. So Kaizen means breaking. Kaizen means small. Sen means improvement. So small improvement. So the Japanese have a concept that even if you do a very small improvement, that the value addition will be more, or you will be getting more profit. So Kaizen is basically small projects which analyze the current situation, and we have to analyze the situation and just make it better. What we can do it better, etc. That's a small improvement which is being implemented. That's called a Kaizen. So Kaizen means change for better. It is a Japanese word that has been implemented in many organizations as part of continuous improvement. So Kaizen will give an example for the continuous improvement. So that's called a Kaizen. So Kaizen means change for better. It's a continuous improvement. So Kaizen, there will be a lot of workshops which involve the team from various activities, from various streams, which leads to a significant improvement in the process. This creates and manufactures the cell. A change for better, or you can see a typical Kaizen breakdown because there are so once you have it, because have a Kaizen system, first we should learn about the 7 ways, etc. How to the tool data management and the resource methodology which we follow. Then after that we have to make the process. We have to analyze the current process, etc. And based on the current process, we have to do an improvement, the shop floor improvement. And based on that, finally we have to do a refinement of the improvement, etc. We should have a standard work practice, etc. Then we have to carry out the jobs without effective implementation of the visual management. So that will definitely lead to value addition in the process. Then another term is called a JAMA. So JAMA is basically a term. There's also a Japanese term which means the real workplace. So if you put there, that means the concept is like that. Whenever any value addition activities are carried out, that only be carried out by the client, then it is called as JAMA. So here the manufacturing. So that means if you go to JAMA means you go to the workplace and see what is the real improvement happen. So if you have a shop floor issue, what as a manager or what as a general manager, what we have to do is we have to visit the site. We have to analyze the problem. So without that means you are going and directly with the site and you are analyzing the problem rather than getting information from different people. So that may lead to the good value addition, etc. So that's called a real place. So JAMA, generally we do a JAMA audit, which ensures that the process being audited by the respective people, and they find improvements, etc., based on the visit, etc., and that will be implemented, etc. That is called JAMA. So JAMA basically focus on the place where the products are manufactured. The term is often used to stress that real improvement. So we can see the real improvements in the workshop floor, which focus on the current conditions when the work is not done. It's called a JAMA. So generally, if you install a new machine or if you are doing a audit, etc., what we have to follow is we have to do a JAMA audit at the workplace so that you can ensure that the process is not being 100% under control. So any changes is there, we can have a look. Because similar type of technologies are being followed by different organizations. So as a expertise in your field, you can take this to the situation here, procure new materials, do a JAMA audit, and we have to find the observation with to some three, four findings, etc. That will be implemented. So that may lead to the reduction in the JAMA. That's called the concept of JAMA. So Japanese, they have identified the 5 golden rules of JAMA as part of implementation of lean manufacturing. First is the key to Japan's competitive success. So basically, Kaizen is the key to Japanese competitive success. So the first golden rule. There are 5 golden rules of JAMA. The first is when a problem appears, then we go to JAMA. First, we have to see the shop floor, and the shop floor or equivalent, we have to go there. Then the second golden rule is check with the relevant objects. We have to check with either you can use a measuring equipment or tools to identify the problem and define the causes for the problem. Next, we have to take temporary countermeasures. So once you analyze the problem, we have to find what is the root cause of the problem. So that comes to the golden rule 2. Golden rule 3 is we have to take an action. We have to find a solution for the problem. We have to implement that. That's called then rule 4 is to find the root cause of the problem. Once you find the root cause, then we have to implement that. Then 5 is standardize to prevent reoccurrence. Once you find a solution, we have to standardize the solution so that it prevents the occurrence of the problem. So JAMA rule is used for improvement in the workplace, and if you have any specific problems, first we analyze the problem by going to the workplace, then analyze the problem, find the root cause of the problem, then you find a solution, then you find that the solution you have taken is correct or not. That's the 5 golden rules of JAMA. And standardization is the managing part of getting good JAMA. So you have to make a standardized workforce in all activities, standardized practice, so that the JAMA can be made very effective. So that means it will lead to better improvement, elimination of waste, etc. by implementation of standard work practices. So in the JAMA, there are different methods of finding the root cause of a problem. So first we have to find the problem. So we have to find the root cause of the problem. So we have to find based on the root cause of the problem, only the solution can be applied for that. So there are different methods of finding the root cause of the problem. One is called a 5-why method, which is also a Japanese word. So you have to ask yourself why. Then again, if you get an answer again, you ask why. Like the fifth why will give an answer for the problem, etc. That's called a 5-way analysis. So if you have a problem relating with a question, then we have to ask five times why. The fifth why will give an answer for the problem. That's another basic approach which followed for lean manufacturing. Then another basic concept which is followed is called a PDCA approach in lean manufacturing. One is called a plan, do, check, act. It is called a Deming cycle, wherein first if you want to do any Kaizen programs, etc., first we have to plan what is the achievement, what is the level of achievement, or what should be the focal point, and what will be your target in terms of quantitative manner. Then you construct a Kaizen, or you have to find the root cause of the problem. We have to find a model of excellence, etc. Then we have to align the activities. Then we have to act. Once you align the activity and you have to carry it out, you have to celebrate the success, etc. by the improvement process. So that's called a plan, do, check, act, PDCA approach. This I told you, the 5 S. 5 S is one of the most important tool to maintain the cleanliness of the product in the workplace. So the 5 S absolutely needed. 5 S which sweep, standardize, self and discipline, etc. It takes care of the safety aspect and then safety and security. This 5 S is very simple and gives a very good benefit. And each organization, individual in the organization is asked to get the overburden items, etc. And once the product during the 5 S, all the items will be tagged either by a green tag, that is equipment which are being used or the raw material which are being used in the process. But it also a system called red tag. If you don't want the material for the last 30 days, or if you have the machine not needed for the 30 days, so what we have to do is you have to put a tag, and based on the tag only, there will be a disposition committee which will disposition the material, and based on that, it is passed or dated based on the needs rise early at the end. So basically, the red tag system is a strategy of grouping the people through plan and putting red cards on everything that which has been not used for the last 70 days. That's called a red tag. You can see a typical 5 years in a factory. If you have a factory to Toyota, etc., you can see here what the cleanliness of the factory, how it has been improved. by implementation of Toyota. This is another area, the office, where before 5 years and after 5 years, you can see the difference. Then coming to the standard work, that's so that I have told you. The standard work in the sense, so we have a resources like manpower, equipment, materials, all these should be a combination of that. So all should work at the same time, or their activities leading to the standardized workforce, etc. The standardized work means talk time, work experience, and standardized work in progress, so that we can manage the standard workflow. So importance of standardized workflow. If you have all the standardized workflow in hand, it means that the improvement efforts in Kaizen to eliminate the waste are not sustainable. You will go back to the original position before Kaizen. You can see, even if you have a Kaizen in place and we have a waste elimination practice is not there, still we can go for the standardized work practices. For standardized work practices, we have the different types of layouts, like manufacturing cells. I told you one of the major factors I told you about this is layout. Plan layout is, so we have the line layout where the assembly cells are being preferred configuration. It's a line balancing under demand fluctuations. You can see that there are different types of cells in which each of the workers or employees have been associated with the different cells to carry out the different jobs, and there will be n number of jobs carried out in all the cells. Then we have the workload balancing. So the workload balancing aims at maximizing the operator utilization based on the given talk time. It gives adjust the JIT lines to the demand lines and occurs flexible operators. You can see the production balancing in a lean model. The product should be easily flown from one process to product, so that there should not be any held up. So that's called a lean balancing model of production line balancing. So there are a lot of theories of attributes, because use JIT to eliminate the inventory, which lean manufacturing builds system to help the people to produce a perfect part every time, reduce the spares requirement. It educates or train the suppliers, develop close relationship with the suppliers, elimination of all the value add, but value add only they encourage only the value add activities. Non-value activities will be screening out, develops the workforce, makes the job more challenging, reduce the number of job classes, and build a worker flexibility. And this lean manufacturer adopts the principle of total productive maintenance. Now let us see how a Toyota system works. So basically we see lean manufacturing is implemented very well in Toyota. So there are different steps created by Toyota in implementation of lean manufacturing. First is specify value. So first they define the value from each of the customer. So customer, generally, if you have a customer, so they express their value in terms of money or in terms of love, etc. So first we have to express the value in terms of money requirements. So second is value stream mapping. We have to identify the critical activities which is being needed for the business. So that's called a value stream mapping. So we have to, through the value stream mapping, we map the process, and we have to see what are the activities needed for the current situation and which are not needed, etc. And that, so like they will give it as a feedback, and that will be taken as a value stream mapping. Then we have a create continuous flow of equipments, like there should not be any bottlenecks in the process. There should be continuous flow of materials from one station to other. Then of course I told you to create pull production. Toyota also follows a pull production, then perfection. Once to make the product, then they have to make with reduced time, any improvement is needed, that need to take. So these are the 5 steps of lean management. First we have to find the value, definition of the value for the customer, and we have to express the value, customer value, because anyway problem is there, customer value in terms of the product. Then we have to do a value stream mapping by mapping of the different management tasks and how that it is being fulfilled, etc. Then we have a continuous flow of materials. Then we create a full production. Then we have to make it a perfection. So this is the 5 stages of Toyota lean production. So basically there's a concept called a lean and green. So lean and green. Lean is basically, it's a concept which involves it's a green engineering. So it's which involves the objective is to reduce the natural resources and to have the limited resources so that it will be useful for the next generation, and it is more environment related, environment friendly, etc. So the green engineering is a system level approach to the product and process. So where the environmental attributes are being treated as independent objectives, etc. So all the activities like lean. So lean is going along with the green. Then only it becomes a perfect lean. So the consumers are become more environment conscious, and which we have limited resource only. So that with the limited resources, with the reduction in the carbon footprint, should create more environment friendly decisions. So it can be linked with a green engineering, etc. The lean manufacturing. So the lean manufacturing is basically is a business model and collection of the tactical methods that emphasize the elimination of non-value added activities by delivering the quality products at the lower cost with the greater efficiency. And the 6 goals of the green engineering are: select the low environmental impact materials, then we have to avoid toxic and hazardous materials, then we have to choose cleaner production process, then we have to maximize the energy and water efficiency, then we have to design the waste minimization program, then design for recyclability and reuse of material. So as population grows or waste increases, the fossil fuels are being diminishes and there is nothing to be replaced them. So consumers become more awareness on the environmental products. So lean and green is so important to reduce the consumption of the natural resources and to optimize the resources, and we have to reduce the carbon dioxide concentration in the Earth's atmosphere, thereby reducing the carbon footprint. So the lean and green manufacturing, the difference is that green actually designs the product or process with the environment as a constraint, with the lean creates the process with the considering the environment as a valuable resource. So thank you. This is what finally I conclude about the lean. So I will be showing a small video of that process of the lean manufacturing.
Thank you so much, sir, for very informative session.
I will show a video also. After it's a 4 minutes video, then after the video we can have an interactive session. Is it okay?
Yes, you can, sir.
Manufacturing is about reducing or removing waste from within a system or process. It's safe to say then that lean companies only make enough products to meet real customer demands. Therefore, no inventory of finished goods is maintained. A pull-based system of production and distribution is demand-driven rather than forecast reliant. A pull system basically limits the amount of work in process, WIP, that can be in the system at a given time. Replenishing of supplies or production is determined according to actual customer orders that have been received. The sale of that product has already been negotiated. A pull environment will come from real demands and products only made to satisfy real orders. A work item can only be in process if there's a demand for it. This environment can be found or set at any level within an organization. We can visualize it on the production floor as well as in the flow of information between departments. A pull system is a control-oriented system that operates by receiving signals that more production is needed. There are 2 different types of pull systems: sequential and replenishment. Sequential pull is where the downstream personnel pulls parts from the upstream supplying process in the sequence in which the prior step produces it. Sequential pull limits the amount of inventory between the 2 steps of a process. The ideal output is one-piece flow. When we refer to one-piece flow, we mean that sub-assemblies are moved from step to step, one piece at a time, or a small batch at a time, minimizing work in process inventory. Replenishment pull is where the downstream personnel pull parts from a storage location according to what they need to complete their tasks. This is like how a supermarket works. So replenishment pull systems are also called supermarket systems. The parts removed from the storage location or supermarket are replenished by the supplying process. Lean uses a concept called Kanban, meaning signal in Japanese, to manage this type of pull system. Kanban uses cards to signal and communicate the need for more supplies. In the context of the flow of information, a pull system allows employees to pull their next task if they have the capacity to start working on it. This helps them to better prioritize tasks and prevents overloading, helping employees stay focused on executing the work. Let's visualize a couple of examples that would represent manufacturing pull systems. When standing at a workstation along the production line, we notice that there's only one footprint for the sub-assembly, which can be placed between station 3 and station 4. This is limiting the amount of work in process that the operator at station 3 can produce. Upon removal of the sub-assembly by the operator at station 4, the empty footprint signals the operator at station 3 to replenish the sub-assembly. This control condition clearly represents a pull system in place. Another case would be when a box of components is being consumed and a card, a light, or other signal allows material handling to bring over another box to ensure no interruption to the workflow. A pull system triggers the action only if the WIP limit has been met. In this case, the WIP limit is met when half the box of components has been consumed.
Hello. Yeah.
Thank you so much, all the participants, for your active participation.
Thank you.
And last but not least, thank you, Venugopal sir, for taking out the time for the session. With your permission, I would like to end today's session here. Thank you, sir.
Okay.